All right. Hello, everyone. Thank you for coming. Today, I'm going to tell you the tale of the Gradle DSLs. I'm Paul, and I do Gradle stuff. So, once upon a time, 2008, Hans and Adam started the Gradle adventure. And at the time, Groovy DSL was hot. Groovy itself was hot. And Gradle was built around a DSL made with Groovy. Started publishing version early, and it took like a few years to get to a first table. Then later on, Kotlin, the new kid on the block, came in and disrupted this, and we started experimenting with Kotlin for a few years, and then the Kotlin DSL in Gradle was born and got stable, and now we are challenging this with a new approach, a declarative approach. So we'll go over this history in steps, chronologically, talking about Groovy, talking about Kotlin, then talking about Groovy, declarative, and the future. So let's start with what makes a build language great. At Gradle, we think there are multiple aspects to this. First, it needs to be understandable, comprehensible, and express things in a clear way. Then it needs to be scalable in the sense that it should work with projects of any size, like small ones, but also large ones with many projects. And the other dimension is the complexity. Some projects are simple, even if they are big, but some projects are complex with complex build logic. The next one is the reliability. Like, it should be dependable. You should be able to know easily what to expect. And the tools also need to know easily what to expect and how to work with it. And adaptable, of course, to be adapted to a variety of scenarios. And our DSLs, they have basically three audiences: software developers, build engineers, or plugin developers. And I'm pretty sure most of you have already wear like two of these hats, right? It's not like a single person each, it's activities we have. And software developers, they don't wake up in the morning saying, oh, I'm gonna run builds. They are like building software, shipping features, fixing bugs. They want a build system they can understand. They want to change simple things, tweak, move on. So the comprehensibility is the most important aspect there. And build engineer, they want the power. They want to be able to do anything they want, automate things, reuse, and so on. Plugin developers, they want a clear contract between them and their users, right? And the history of the Gradle DSL I'm telling today is the story of learning how to serve these three audiences. So let's start with Groovy. So like I said, Groovy started in 2008, stable 2012. And Gradle was getting momentum, and the Android team that was still using Ant at the time to build Android applications decided to use Gradle as a foundation to build their build system. And that brought like a lot of users. So a lot of Groovy DSL users. And soon after that, we delivered the plugins block, which is quite foundational in this progress, we'll see. So that's young Groovy DSL. Groovy DSL in its infancy. And it's hard to make sense of it because it's words, it's applying plugins, there are conditions, there is code. It's code, right? And when you look at this fictitious example, it's quite hard to know what to expect depending on the environment, because it depends on the environment. Like, there is some magic there, also. It's groovy magic, right? If you have a small build with one build file like that, it's fine. But if you start to have like dozens like that, and I've seen some atrocities of like 2,000 lines of that in one build script, where there are like 100 build scripts. But then, what can you do? Like, it's unmanageable. And so Gradle 2014 introduced the plugins block and plugin extensions. So the plugins block is a way to declaratively say what are all the plugins that are applied to your build, right? And you put that at the top of the build script, and when you look at a project, you look at his build script, you know what are the plugins that are applied. There is no hidden condition, and so on. And the extensions, they expose a DSL. That's the Java block here, with things you can configure. And with this introduction, Gradle started recommending to keep your build script declarative. Don't put arbitrary code there. But there's nothing that still prevents you to do the same. So what are we doing? And there's more to it. Like, in Groovy, every character is code, basically. It's like a dynamic message passing language. And the compiler has basically no idea what he's compiling close to. And when there is a word that doesn't map to a known member of a type, it ultimately gets to Java reflection on private members. That's a big trap. Like, how can you reason about something like that? And about IDE support, sure, you can get syntax highlighting. That's easy, right? But when you get to completion, for example, it's very hard, like, for a tooling to reason about Groovy, because it's fully dynamic. So completion is anemic, or it's lying. You cannot depend on it. And code navigation is just basically a gamble. So IDE support is sad. But this all boils down to static analysis, because with Groovy, basically static analysis is close to impossible. And one example is the Groovy compiler doesn't know how to emit a deprecation warning. Because it can't. Because it doesn't know what you are using. It doesn't know what your code means. Right? So what does that mean for our personas? So it's powerful, but it's magic. It works, I don't touch it. Like, I'm sure that resonates with some of you, right? But it comes with a lot of flexibility. You can express anything. You can do magic tricks. But again, the plugin developers, they want a clear contract, and that's not there, right? So the root problems we had with this DSL is the lack of type safety, right? Because with type safety, we could have compile checks, compile time checks, auto-completion, navigation that is dependable, and things like that. And the other one is that there are no clear boundaries between the definition of what the build is, like the configuration the software developer would look at, and what the build does, like the build logic. So Groovy doesn't fit the bill, right? And the moral of the Groovy era is that with great flexibility comes great, no, that's not it. It's with great power comes great responsibility, but the responsibility is on you. And that's the bad part. And we could sum it up as like, when everything is possible, nothing is obvious, right? And you don't want to be there. So here comes Kotlin, the new kid on the block. And so around 2015, we started making experiments. It was very exciting. The partnership with JetBrains and the Kotlin folks was great. We got it stable in Gradle 5, and thanks to some person present in the room that help at Google and JetBrains, the Kotlin DSL became the default in Google IDEs, JetBrains IDEs, in Gradle documentation, etc., around 2023. So with what I said earlier, you already know why we moved on, right? But how we did that? We actually kept the same Gradle model underneath. It's just that scripts, instead of being Groovy, were Kotlin scripts compiled by the Kotlin compiler. And it makes the typing, the static typing of the language flow from the plugins to the scripts naturally with support in the IDE and so on. And so software developers, I think, are happier. We have a lot of signal about this still. Of course, we are software developers, so we can be grumpy, right? But we get auto-completion, code navigation, all that fuzz. Build engineers, they get also their share of benefits. Plugin developers, same. But it comes with trade-offs, right? So the first one is that it's a bit more verbose. Like in Groovy, you can omit parentheses. You can use simple quotes. In Kotlin, the syntax must be explicit. So Groovy was a bit more concise. And there is, of course, the migration cost, right? It requires effort. And below the migration cost here, when you stumble upon a plugin that has an API that is not perfectly type-safe, didn't migrate properly to this new era, then you have to use quite convoluted APIs to look things up by type, by name. And the last trade-off is the script compilation time, because like I said, the Groovy compiler doesn't do much, so it's very fast. The Kotlin compiler is doing a lot of things, so it's not as fast. So there is a cost there, right? So that's the same build script with the plugins block that we saw earlier. It looks similar, like I said, like parentheses, double quotes, but it's the same. But there is still nothing that prevents you from doing weird stuff. Because this is still imperative scripts with logic. So you can shoot yourself in the foot and make a mess, like make complex builds. So if we go back to our root problems, Kotlin brings the type safety. Check. But it doesn't help with the clear separation. So along the way, we are learning that we are not serving our audiences as good as we could because of this. So the moral of the Kotlin story is that, of course, static typing is a net win, but it's not enough. Because when everything is typed, but anything is still allowed, like still no guardrails. So that's with this in mind and in this spirit that we decided to take a declarative turn. We started experimenting and exploring 2 years ago, and declarative Gradle, as it's called, is still experimental. Again, I explained why we are doing this. And so we are doing this with a restricted DSL. It's basically a configuration language. It's not a programming language anymore. So you cannot have your for loops. You cannot have your comprehensive switch cases. You cannot have your data objects. You cannot have all that thing. You cannot have classes. You cannot have functions. It's just configuration. And all the logic then lives in plugins. And that clear separation helps humans reason about a build, because when you open a build, then they look very much the same. It's just configuration. There is no, I invented some crazy logic in that build script in that corner that will be the surprise for the next person looking at it, right? There is no more that. And tooling then can also reason about it properly. And what we want to bring to our audiences with that is the focus for software developer. Again, a software developer is not starting work in the morning to fiddle with build scripts. They want knobs to build their features and fix bugs. And the build engineers, they can now, and both build engineer and plugin developer now have a clear contract between the build logic and the configuration they can expose to the software developers. Like in big teams, it happens quite often that there is some folks responsible for the build, right? And we have like horror stories of people fighting their developers. Because of course, developers, they want to get things done, so they do the quick thing, but they leave this surprise in the corner of the build, right? And having the build script be configuration only help with that, because then there is a clear separation for the mental model, also for everyone it's better. And so how that's basically the architecture we came up with. It's not so much different, but there are some key properties that make it very different. So on top, you have like the plugins. We still have plugins, right? Where folks from the ecosystem, like us with the JVM plugins, Google with the Android ones, Kotlin with the Kotlin ones, Spring and others, will provide like plugins for their ecosystem with types of projects, like project types, we call them. I don't know, like a Java application, a Kotlin iOS application, a JVM library that targets multiple runtime, etc. And your custom plugins or community custom plugins, they can live on repositories or locally, right? And the difference is that what these plugins expose to Gradle is not just build logic, but build logic and fragments of schema for the data that is configured, right? That goes with the build logic. So the what and the how. And Gradle composes this into a unified schema for your build. And that helps tooling, because then tooling can get the schema and know everything that can be configured in that build without configuring any project. And that's a key property of our strategy, meaning that even if you have a configuration error somewhere in one of your projects, the tooling can know the schema and can reason about your build definition, your build configuration. And so that means, like, if you have a build with, I don't know, 200 sub-projects, you can get the schema in hundreds of milliseconds instead of having to wait for configuring everything. And in your project definition, no more plugins block. You define the type of your project. Here, a JVM application. And check style, for example, is an extension. So up there is a plugin that provides the JVM application project type. And there is a plugin that provides the check style feature with the metadata necessary to bind them together. So what we have today is this extensible restricted DSL with an API for composing the build logic of plugins. We have prototype plugins for JVM project types. The JetBrains folks did build a prototype plugin for Kotlin. You will hear more about it during the conference. And Android, they did also build a prototype for Android libraries and Android applications. And we have, thanks to our collaboration with the Android Studio folks and the IntelliJ folks, supporting the IDE. And we built a language server to provide support in other IDEs. But all this is still experimental, of course. You can learn more at declarative.gradle.org, easy to remember. So let's take a look. So what are we looking at? This is Android Studio. And what I did here is I'd say new project, empty activity, whatever. And there now I can pick declarative. This is behind experimental flags that are documented on our website. And I still have to use development version of AGP in that case. And I will not click finish here. I did that already because the network connection of the artifact is slow, so let's not waste time. And what you get is this. The only thing I change is I'm not saying hello to the world today. I'm saying hello to you. Hello, Kotlin Conf. So, but that's not the interesting part. So this is a regular Android build, right? And what we can see already is that the files are like these DCL files. And yeah, that was just space. And the settings did not change much yet. But we did not focus on the settings yet. But basically, you bring plugins, as usual. And here you see that's the Android ecosystem plugin. And in declarative, we have a way for the software developers, without going into build logic, to define conventions. Like in Gradle, today you use convention plugins to define like command defaults. But in declarative, you can actually do that in the settings directly. And here you see, OK, I have the Android ecosystem plugin. And here are the two things that it provides today: Android app, Android library. We can already see that the IDE completion is nice because it's tiny. You don't get like 1,000 cuts. And so you can configure the defaults here. So you could say, OK, I want the compile SDK to be defined there, and it will be defined for the whole build. And so this is in the hands of the developer. It doesn't even have to go to build source or build logic. And if we look at the build script, looks familiar, right? But there is no plugins block. There is nothing. It just says, this is an Android application. And then the rest is declarative. And again, completion is very narrow. You only have what the Android plugin provides. So you cannot make a mistake. You cannot like reference a scope from another scope. Like there are a lot of traps that disappear. Like if I look into there, I only have one thing because there is only one thing I can do in this block. So it's much easier to discover what's possible and to reason about what's possible. So what this means is you can build Android apps with declarative today, right? OK, living on the bleeding edge, but you can. Now we'll look at another project. It's the Spring Pet Clinic, but ported to declarative. Thank you, JetBrains folks that worked on this. And they are using the JetBrains ecosystem plugin here. And it's the same story, right? Currently, it provides JVM app, library, web app, things like that. And if you look at like shared, just a library, this one is a web app, and each time you have like a tailored completion, you got the point. And so how does the IDE support work here? It's basically the IDE, like I said earlier, can query Gradle for the schema of the build. And what defines the schema of the build is the settings plugin, like the plugins that are applied to settings that are bringing the types of projects and the features that can be combined with them. And the IDE can query that very early without even configuring the projects, without downloading the dependency. It will still download the ecosystem plugin, but that's it. So even if your build is broken, even if your build is huge, the IDE will be able to support you very early in the process. So again, this means that you can start building some Kotlin applications with Declarative today. So now we'll be looking at another project that we came up with. It's a fictitious 40, 50 sub-project build. Like it has almost everything. And it doesn't use the JetBrains and Android ecosystem plugin. It uses our own experimental plugins for JVM. So in all cases, like the Kotlin one, the Google one, and ours, they are like just shells above all the tooling that existed before. So it's the same tasks, it's the same goodness and reliability that we are used to. So you can try. It's just the surface of Declarative that is experimental. And we had a draft KMP thing on our own, and we did not update to the official prototype plugin from JetBrains. And it as well as like custom local ecosystem plugin in BuildLogic. And so yes, there are multiple projects. So if you go into defaults, then you see all the types of projects you can get, like Kotlin, JVM, and this client app, which is actually a local plugin. So you can define your own types of projects locally. And it has some extensions. Like this is, detect is not part of vanilla Kotlin support, right? So it's something that you get here. And you see the same thing, Java app, right? And you see like check style here is also an extension that was contributed by a separate plugin. You get it here. And this one is a Kotlin library, and it has this SQLDelite configuration. And that's an extension that we can find locally in BuildLogic plugins. If I look at the features, I see SQLDelite, right? And if we look at the shape of the configuration, that's how today in Declarative you define the shape of the configuration you expose in the build script. It's an interface with data-oriented API where you say, okay, I'm configuring the version and the databases, and each database has package name, blah, blah, blah. The things we find here, right? And of course, you get the narrow completion, as always. And so this guy defines the shape of the data, right? And this is our plugin development APIs there, where we say, okay, we had a feature named SQLDelite. This is the data, and it attaches to anything that is a Kotlin multi-platform project. And that's how this makes SQLDelite available here in a Kotlin library, right? But it's not in, let's say, this guy, which is a Java application. There is no detect, right? and then an apply action. And that's the build logic part. This is, it's not declarative, but it declares the bindings between things. And it's separated from the build logic being basically a function. And then you can configure things, have access to creating tasks and things like that. I won't go into the details, but there is a plugin API around this. So we see that you can build Android apps, you can build Kotlin apps, and you can extend things with other plugins. So talking about the JetBrains Kotlin ecosystem plugin, there is a talk dedicated to it tomorrow morning by Marcin. I recommend you to go there. And the QR code is for the link to the GitHub repository for that ecosystem plugin, where you can find documentation, examples, and things like the Spring Pet Clinic. All right, so back to our root problems. Type safety, check. DCL as a type system, it's tiny compared to Kotlin, but it's strict. And we have our clear separation. The configuration on one hand for the software developer and the build logic on the other hand. And in the middle, this API for composing things. So today, with Declarative, we answered the hard questions we had during our experimental phase. It's usable today. We know some folks, we know some teams that use it in production, living on the bleeding edge. But, as you saw, there is quite a ceremony. Like, I went through the code quite quickly, but there were like a lot of things around it, right? So you need to write an ecosystem settings plugin, a feature binder, definition schema, like way too much of it. Way too much of it. The usage part is nice already. But at our stage of this endeavor, we think it's too much. We are at the peak of complexity, right? We solve the problems, but it's complex to use. And Gradle has always been something, at least for me and some other folks, maybe I'm in my bubble, but easy to love in the sense that at the beginning, right? It's like every love relationship. You can do like little things very powerful very quickly, right? And with all that ceremony, we lose that. It's a trade-off. Is it worth it? Can't we do better? So we're looking at doing better there. And our thinking is that the schema is the source of truth, basically. You start, and you should start by this, like define the shape of your DSL, not by writing classes where there is code. And it should be constrained because, like we looked at this, it looks nice and tidy, but it's code. So as a software developer, I'm tempted to do like funky stuff. So we want to constrain this so it's clear, it's more clear. And reduce the boilerplate, like Gradle will take care of it. This is fictitious, partly, but we were thinking like what's the smallest declarative plugin possible you could write, right? So you define a schema. There is some repetition there. I'm not happy to say small twice, but and the build logic is basically a function that will take this data and work with the Gradle model and a usage, right? So if we go back to our project where we had the SQL Delight thing, and let's look at how the detect one is implemented here. So it's there, and I have a detect schema. It looks familiar to the previous slide, right? And so this is a sneak peek preview of an ongoing exploration. right? But we are looking at feedback. We want to show the user experience we are trying to chase here. And so this is an extension named detect for a KMP definition. And here I can do extensions, records, templates, traits, types, things like that. So it's a tiny schema language that comes built in with an extension model. It models the extension system that is needed for a DSL like Gradle. And so here I just say, okay, that's my data. And I cannot put any code there. So again, it's constrained. And I have my KMP definition. It's a trait. And so, and I have two templates, KMP library. This is fictitious, right? So I have the Kotlin library, Kotlin application. Those are project types of projects, right? But they share something in common, that they are a KMP definition. And I can have the shape of the data needed for each can be different. And then I can say, okay, I'm defining a schema to extend all KMP definition with detect. And this is a prototype we use. It's a language server behind it to provide the work here. And then Gradle generates double or plate. That's what we are exploring. And we get to the build logic function only. So there is still some ceremony, but we're looking at like narrowing it down. So it's, again, a sneak peek. And then you have regular build logic that maps the data to the Gradle model, like configuration, tasks, etc. So another thing we are looking at is, with all the craziness about AI agents today, we actually have a new audience. And this audience is the AI agents, the coding agents. And they have needs that are similar to us. Like, we can cope with complexity and ambiguity. For AI agents, it's harder. And they need structure, not flexibility. They need something constrained. And particularly, they need something self-describing, because they cannot make sense of anything. They are just interpreting. So I will show you a prototype we built on Declarative. It's a recorded demo, because I have no trust in having the model available at the time of the demo and things like that. So bear with me. So we are looking at the same project we were looking at, right? We find the services, the tooling, the same project. And it has, let me skip that part. And we have this Kotlin application, right? The same settings with the defaults and all that. So, and we see detect here. So here we start a Cloud Code session. We will accept edit, because we will want it to change our build. And we use a plugin that we have been building. And with that, we ask Claude, like, give me an overview of the different types of projects in the build. And it loads the skill we came up with. It's tiny, because it points to next this agentic tool, poor name. It's a command line tool we prototyped that allows the agent to do what the IDE does, like query the build for the schemas. And that's what it's doing. It asks for the project types and features, the list of projects. And it can give us an overview with like project types, how many projects. So that's what we asked, basically, right? The custom one. The pluggable features in use, we see detect, SQL Delight. And this did not require configuring any project, so it works even if your build is broken again, right? And to see how we can, like, it can discover things, like we ask, what are the available Kotlin code quality reports that are machine readable? And if we look closely earlier, the schema for the detect implementation was documented, right, with all the reports. And the agent gets that same data from the build. But it gets only what's available in this build, right? Not the world, just tailored to your build with custom things locally. So Sarif XML. And now we say, okay, I want the Sarif and HTML reports enabled everywhere and disable all the other ones. And it goes on. And it will succeed. It makes the change. All right, it's done. And so the tool is basically a command line tool with options, and it outputs JSON, right? And in which we actually can find the doc, right? No magic. That explains how the agent got all this. And nothing changed here. The only thing we did is, in that part, we replaced the connection from the IDE to Gradle by just a command line. So it's the same model, confirming that the declarative architecture is looking good. So where do we go from here? This is an ambitious project, and the results are very promising, but it's a lot. And like we said, we are at the peak of complexity and trying to go down that slope of making things much better. So as of today, we are slicing the scope in order to ship what matters most first. And what matters most first is the schema first, extensible DSL part. Not much the plugin collaboration APIs that we had to come up with in order to solve the composability questions we had. But we want to ship the DSL first this year. It will be incubating at first and go to stabilization. While we're doing that, the Groovy DSL and Kotlin DSL are fully supported. Don't run scared away from this room. And they continue to evolve. Like, we have to evolve the Groovy DSL still for the configuration cache and isolated projects, so we keep taking care of this and of you. And we are considering this long-term vision where declarative is the single declarative language, eventually. But it will require maturing the declarative ecosystem, of course. So what can you do today to prepare your build? Use the plugins block, right? It's been 13 years we're saying that. Keep your build script declarative, the same. Don't put arbitrary code. Version catalogs are nice. And the main recommendation that goes with the declarative feature is one plugin, one project type. Like one project, a single plugin applied that say, okay, this is my backend library. This is my front-end library. And have your convention plugin aggregate the other plugins needed and the configuration. And maybe expose only the knobs you want to your software developers. Of course, avoid arbitrary code, task configuration build script, and cross-project configuration, because this is, of course, an anti-pattern for isolated project, but also for declarative. And so your builds can be on a spectrum, right, with arbitrary code coupling everywhere to, oh, I'm extracting small conventions. That's how you start. It's the spectrum of existing build, but it's also the journey you should take, right? Extract project type convention, start with this. You still have some coupling, etc. But then you get to pure convention. And you're ready for the future. So, again, prepare your builds for the future and try out declarative. Help us shape the future of declarative. That's all, folks. Thank you.